Hey guys, we are going to take a look at our next concept, which is polynomial functions. We're going to get away from the probability and statistics stuff and get back into algebra. And so we go into polynomial functions, and to start this concept, we just get into a couple vocab terms and ways that we can classify and identify polynomial functions and what they really look like. We keep it pretty simple to start. So the first thing that we're going to talk about in a polynomial function is called the degree. And the degree is just the highest exponent of the variable in that function. So I'm going to give you a couple examples here. If I had a polynomial function and the expression just looked like this, and it was 3x squared plus 2x minus 4, just a simple little expression, I'm going to look for my highest exponent. 2 is my highest exponent, so in this polynomial function, my degree is equal to 2. Pretty straightforward. Another example, if I had 4x minus 3x squared plus x to the 4th, my highest exponent of that variable x is 4, meaning my degree is 4. It's just your highest exponent. So whatever your highest exponent is in that function, that is your degree. There are some special names for that. If you have a degree of 1, that is linear. That means that function will make a line. If I have a degree of 2, that's our quadratics. We've worked with that this year. Those are our parabolas. The new one specifically that we'll kind of see is when I have a degree of 3, and that is a cubic function. And then they could keep going. A fourth degree polynomial is quartic. A 5th degree is quintic. But really, from then on, we can just use the number. But these are some of the terms you might see, specifically those first three: linear, quadratic, and cubic. They're kind of interchangeable. Okay, so that's the first thing, is we can identify a polynomial function by its degree. That'll be important later on as well. The next thing that we're going to look at is its type. And that's pretty straightforward as well. Type is basically just how many terms do I have. So a monomial will just have one term. So for example, I may just have 6x cubed. That's a monomial. There's one term, the 6x cubed. A binomial, by 2. So I might have 6x cubed plus 4x. That plus 4x is my second term. That makes it a binomial. A trinomial, try 3, would mean I have 3 terms. So maybe I have 6x cubed plus 4x, and then I have a plus 7. That constant can be a term as well. So I'd have a trinomial there. And then anything more than that would just be called a polynomial. So if you've got 4 terms, you've got 5 terms, you've got 6 terms, we'd use the term polynomial to represent that. Okay, and then the last thing we want to talk about is called standard form. And that's pretty straightforward. If we have a polynomial function in standard form, it's just written in order by the exponents. So this would be a function in standard form. So f of x equals 3x to the 3rd power minus 2x squared plus x minus 7. Notice that all the exponents are in order. 3, 2, 1, constant term. That would be in standard form. This next one is not in standard form. F of x equals 2x squared minus 3x to the 3rd plus 7 minus x. Okay, they look very similar. This one does not have its exponents in order. Therefore, it's not in standard form. So this is usually the easiest. If I look at this one, it has a degree of 3. And it's a polynomial because I have 4 terms. 1, 2, 3, 4. And the same would be true of this one. This one's just not in standard form. So usually we'll see it like that. Okay. So basic definition of polynomial functions, that's really the key information so far for polynomial functions. And then we'll look at one other topic or concept in this beginning concept, and that is end behavior. And so we're going to start taking a look at the graphs. You are not going to be doing any graphing. Most of the graphs will be given to you. But we're going to look at the end behavior of different polynomial functions. So we started with linear. We had our linear functions. We had our quadratic functions that ended up being in parabolas. This is an example of a cubic function. Okay, it's got that curve, but notice that it's not going in the same direction. And so we're going to look at a few different things, and really you'll notice some things as we go through the definitions. End behavior just tells me what's happening at the end as I'm going in each direction, left and right. So as I go forever to the left, this side of my function is going down. It's decreasing. Okay, so it's going down. Over here, as x increases, I am increasing my y's. I'm going up. We're going to keep it really simple, and we're just going to use the word down and up. So this function right here would have end behaviors of down and up. If I looked at up and down, those are very basic terms, but it would look something like this. As I'm going to the left, it is increasing. As I go to the right, it is decreasing. They can be the same direction. I could have up and up, like my parabola here. And you may see other polynomial functions that end up looking like that. That would have up and up end behavior. And then down and down is another option, another possibility. And you can pretty much think about what that would look like. Basically, you could have a parabola that is opening downward, or you may see some funky functions that look like that. But ultimately, as I'm going forever in both directions, both of them are going down. What you need to be able to do is just be able to identify what kind of end behavior your function is going to have. And so we can look at two different things. I'm going to create a little table here for you just to make this a little bit easier. So we're going to look at two things. We are going to look at the degree of your function, and we are going to look at the sign of your highest term. Okay. So first thing I'm going to look at is the degree. Is it an even degree? If it is an even degree, your ends are going to do the same thing. They're either going to be both up or both down. If that is positive, if the sign of the opening term is positive, then I will have up and up. And don't worry about all the different shapes. We are only concerned about the ends of our graph. They're both going up. That is what our end behavior is really telling us. An example of a polynomial function that may look like that would be f of x equals, now I have a degree that's even, so I'm probably looking at an x to the fourth, and then this needs to be positive in order for them to both be up. Okay, so I'm looking at the degree and the sign in front. So it doesn't matter what's behind here. I could have plus 3x cubed minus 2x, blah, blah, blah. It doesn't matter. I'm looking at my highest exponent. My degree is even. 4 is even, and it is a positive value in front of it. Now, if I take that same function and I keep the degree the same, but I make it negative out in front of that opening term, and let's say I have a plus 3x cubed, whatever. It's still an even function, but I'm going to have down and down end behavior. And so my function is going to end up going down. on the ends. And again, doesn't matter what's going on in the middle of your function, it is all about the end behavior, the ends of your graph, down and down. So that's for even. If they're even, they're going the same direction, either up and up or down and down. For an odd degree, if my degree of my function is odd, okay, if it is positive out in front, so for example, f of x equals positive x cubed minus 2x squared plus 7, something along those lines. My function is going to go down and up. So odd functions go in different directions. So I've got down and up. And I think of my positive one of having a positive slope. So if you think of your linear functions, it's kind of like a positive slope. So maybe a way to remember that. So then if I had a function then that was odd, meaning, yep, okay, x to the third power, but it had a negative out in front, and it doesn't matter what's behind it, then I'm going to have up and down. It's just going to flip that. And so my function is probably going to look something like this, where I'm going up from the left and down to the right. So if it's got a negative sign of my highest term, I think of it as a negative slope. It's kind of going down that way. So I can look at just the function and not even have to graph it to do this. So for example, if I have f of x equals 3x to the fifth minus 2x squared plus 3. If I look at that function, I can tell you what the end behavior is going to be. So I'm going to look at my degree. It is 5. That is odd. Okay. My value out in front of that highest term is positive. That means I've got positive and odd. I know that my end behavior is going to be down and up. It is going to look something like this. I don't know how many little humps there's going to be in there. We're not going to worry about that. Just the end behavior is going to look something like that. Okay, and if I look at another function, and I've got negative 2x to the eighth minus 3, that's my function. Okay, I look at my highest exponent. My degree is 8. That is even. I have a negative value out in front of my highest term. That means I'm going to have down and down. And so my value is going to look, my function is going to look something like that. We don't know what it'll look like. We'll let technology help us with that, but I can at least tell my end behavior. This guy right here is going to be very important, this table, just to help you remember. Okay, so end behavior and classifying polynomials. That is all we are really doing with this stuff.